So, hello and welcome to the first lecture on statistics, where we are going to introduce the formal concept of random variables. So, what are random variables? So, basically, random variables are usually any real valued variables that get their value from a random experiment. And we remind from one of the first lectures on probability theory that a random experiment is basically any well-defined procedure that produces observable outcomes that could not be perfectly predicted in advance. So a random variable is actually the mapping from the sample space of some random experiment into a measurable space, usually the space of any real valued numbers. So random variable is basically the mapping going from some sample space S into a measurable space, and usually this measurable space is the space of any real valued numbers, R. In order to illustrate this rather formal concept, we would like to introduce a particular random experiment, namely the one that we encountered already in previous lectures on probability theory, namely the one of the flip of a coin 2 times in a row. So basically, we have as random experiment flip of a coin 2 times in a row, and we know that the sample space of this particular random experiment has basically 4 different elements. So we can write down the sample space S, which can have like as first element 2 times heads, so obtaining heads for the first flip and also for the second one. It could be first heads and then obtaining tails, or first tails and then heads, or obtaining 2 times tails. So we see that this particular set, called the sample space of this random experiment, has 4 different elements. So now we could actually go and ask for the event of obtaining tails while flipping the coin 2 times in a row. So basically, we can have like 4 different elements. So the one that are contained in the sample space, we can have like 2 times heads, so 0 times tails. And in this particular case, our random variable x will get the number 0 because we have 0 times tails. We could have like these 2 elements. So basically the 2 here contained within the sample space at the middle, and these are heads tails or tails heads, so we have at least 1 time tails, so 1 time tails, and that means that our random variable x actually gets the value 1. And the last element of the sample space is the one where we obtain 2 times tails in a row. So basically our random variable, associated random variable, is actually 2, so 2 times tails. And then we can actually also work out the corresponding probabilities. So basically the corresponding probabilities of obtaining 0 times tails or 2 times heads, which is the same thing, is like, again, boils down to a counting problem. So basically we have 1 element here and the sample space contains 4 different elements. So we have to divide 1 by 4, which gives us 0.25. Then we can actually go and ask for the probability of obtaining 1 time tails, and that is actually the probability of x equals 1, so our random variable being 1. And here again we have to count, so we have 2 elements here, 1, 2, that we have to divide by the 4 elements of the sample space. So basically this is 1/2 or 0.50. And the last probability that we could actually work out is the one where we obtain 2 times tails. So basically x equals 2 for 2 times tails. So probability of random variable x being 2 is 1 element divided by the 4 elements of the sample space, which again produces 0.25. So basically on this side, here on the left side, we see that we recover our total sample space, so the 4 different elements of this random experiment. So here we have the sample space. And we see that our random variable actually is contained within 0 and 2. So basically x belongs to the subset going from 0 to 1 to 2. And this subset is, of course, contained within the set of all real numbers. So in mathematical notation, we have this. And then a last very important point is basically when we compute the probability of all the different elements of the sample space, we have to end up at a probability of 1. So basically we take the sum of the probabilities going from 0 to 2. So basically this is 2 here, and with the corresponding probabilities, and basically we have to sum up these three numbers, and I mean these three numbers, it's quite easy to compute. We end up with 1. So basically this concludes the first lecture on statistics, where we introduced the formal concept of random variables. Looking forward to seeing you again in the next lecture, where we are going to consider a second example where we introduce also the concept of random variables.